This last practice problem is actually going to show up very similarly on your homework. Therefore, let's just pay attention. If we start off from our graph, our x-intercepts, our roots, are -5 and 1. We have our -5, 0, and our 1, 0. And if we remember going from our standard to our, from our x-intercepts using our zero product property, we could say that, we have to switch those signs. So my factors are x plus 5 and x minus 1. And that's going to get me my factored form right away. Now, the problem is, if I were to graph this by itself, I'm going to get a parabola that does not open down. It's going to go up. Therefore, if this parabola opens down, that means your a value has to be negative. So in my standard form, that number out in front of my a value better be negative. So this has many solutions as well. No, this one has many solutions. The one before did not. I don't know if I said that or not, but if I said practice number 1 had more than one solution, I was wrong. There's only one solution on practice number 1. Practice number 2, there are many options here. My a value does have to be negative. So if I use my standard form, I could put my negative value out front there. And when I multiply those together, at first I get, for foiling, x squared plus 5x minus x minus 5. That gets me a negative x squared plus 4x minus 5. But that negative sign is still out front, so I have to distribute that in. And my standard form for this guy is negative x squared, multiplying the negative on the 4x as well, and on the negative 5. And that makes sense because, check it out, my y-intercept then has to be a positive 5, and that makes a positive y-intercept here when I look up at the graph. I'm going to fill that in for what I just found. And there's my standard form. And now I just get to fill in my y-intercept. Well, my y-intercept again is at the end of my standard form. So it's 0, positive 5. My axis of symmetry is always going to be the x value of my vertex. I could use my vertex formula. My x value is going to be negative b over 2a. And I could plug that in and find the x value of my vertex. I'm going to do that here. So my b term is negative 4. So negative 4. My a term is negative 1. Well, negative 4 is a positive 4 divided by a negative 2. That's negative 2. Okay. That's the x value of my vertex. Now I'm going to plug that into my standard form. Y equals negative 2 squared minus 4 times negative 2 plus 5. Simplify that. Negative 2 squared is 4, positive 4, but that negative out front then makes it a negative 4. Plus 8 plus 5. I'm seeing a positive 9 there. There's my vertex. So my vertex, I'll write it over here, is negative 2, 9. And my axis of symmetry is always that same x value again. And so that's x equals negative 2. And if I'm checking these all back every time I do this, does it make sense that this would be an x equals -2 line? Yes. Does it make sense that that point would be -2, 9? Yes. Does it make sense that this is 0, 5? Yes. So we got all our stuff there. And now I'm just going to come over to my table and I'm just going to plug in a bunch of those points that I see. I'm seeing a -5, 0. The next thing I'm seeing is my vertex. That's at a -2, 9. I'm seeing my y-intercept at 0, 5. And then I'm seeing the last x-intercept at 1, 0. And really that's all, folks. So just take a look at the quadratic forms down here at the bottom. I just want you to make note of these right here. We're just studying. If you have questions, get on those optional Zoom meetings on Wednesday. Friday you don't have school, so just keep that in mind. And I'll see you at the Zoom meeting today. It's required. That one is, during the allotted time. And yeah, then I'll see you on the Zoom meetings on Wednesday. That's optional. It does give you some extra credit in the homework category, but again, optional, trying to limit the screen time. You guys are the best. I miss you so much. It's painful. Enjoy the snow, and I will see you soon.